This is Kassi, an AI agent that catches your next bad deploy and writes the fix. Many outages start the same way. A change passes every unit or function test, then breaks under real production traffic. The damage only shows up server-side, so the warning is easy to miss, until production is down at 2 a.m. Catching it early means generating load and correlating it by hand, which rarely happens in time. That's exactly what Kassi automates. It doesn't guess from the diff. It runs the real experiment. Real load against your change, the server-side truth read straight back from Splunk. Every step sealed to an audit trail. Let's see it in action. This pull request adds one endpoint, and every unit test is going to pass. One request at a time, it's flawless. But under real concurrent load, more than half collapse from a database lock the client never sees. Watch Kassi drive the whole state machine itself. It generates the load with K6, reads the server-side error straight back from Splunk, and the AI toolkit confirms the spike is real. It names the cause, database is locked. A second model checks that the write-up is grounded in the evidence and that the fix it writes is a real reviewable diff. It calls the regression before production. And it's not a black box. Every step it took is on a tamper-proof ledger that you can replay and verify. It even reports on itself. The verdict and the agent's own path through the state machine land in Splunk. Observability guaranteed. Now, a different change and a tougher catch. This one just gets slower, with 0 errors, so every error rate alarm stays quiet, and a short test looks perfectly healthy. But let's see if Kassi flags it anyway. It leans on the Splunk AI Toolkit's forecast, which sees the latency climbing toward the wall and calls it before it hits. No error ever fired. The only warning was the trend, and it writes the fix here too. Bound the runaway store before users ever feel it. And just as with the previous demo, we're going to have the same audited trail, every step replayable and verified. A completely different failure, caught the same disciplined way. 2 changes, 2 signatures, 1 agent, and the dashboard tells them apart at a glance. And it's measured, not just demoed. 0 false alarms on our own live benchmark and on a recognized independent RCA benchmark. 1 agent, 2 MCP servers,